Hi, this is Richard C. I'm answering a question it was submitted by a student about linear programming. So linear programming problems always come in two parts here. The first part is a statement of constraints. And when we plot each of those constraints on a graph, the intersection of those constraints produces something called a feasibility region. And then the second part is we need to figure out what point in the feasibility region gives us a maximum or a minimum value of what we're trying to optimize. So I got started a little bit on this because I don't want this recording to go on and on. So we have 10 acres to plant in either wheat or rye. So I let X be wheat, Y is rye. And we have to say that we're going to plant at least 0 acres of wheat and at least 0 acres of rye. Those are constraints that we have to put in there. And then we're told that we cannot plant more than 10 acres, but we have to plant at least 7 acres. So this first one, less than 10 acres, this is the equation plotted on the graph. You can see we're only looking at the first quadrant because X and Y both have to be positive or 0. Actually, they can't be 0 because we have this constraint. They can't both be 0. But in any event, this is the first line. When X is 0, Y is 10. And then when X is 10, Y is 0. And then this is the other line. When X is 7, Y is 0. It's down here. When X is 0, Y is 7. It's up here. Okay, now the other constraint has to do with money that he has to spend to plant. It costs $200 to plant wheat per acre and $100 to plant rye. And he only has a budget of $1,200. So I'm just rewriting this into slope-intercept form, make it easier to graph, and that's what we're going to start off here. We're going to graph this. And when X is 0, Y is 12, so I need a 12 up here. Okay, when Y is 0, X is going to be 6, so I have a 6 here. And so I'm going to have a line that looks like this. And so the solution region has to be in this area here. Let me get some color going here, make it a little easier to see. This is going to be the solution region. And then the next step is to find these points here that define the region. And that's done pretty easily by just setting this equation here, this one, set that equal to this one here, and you can solve that way, and it doesn't take very long. I just want to show you a graph that I did so you can see it better. I think it's still a little hard to see. No one ever said my artistic skills were that good. So I did this graph ahead of time. And you can also see it a lot better. It's drawn to scale and so on. And you can see from here the solution region and the corners. So there's a theorem in math that says the maximum or the minimum of any optimization is going to occur at the corners. So what you do is you just set up a table for yourself. So we'll have X, Y, and P for profit, which is going to be 500 X plus 300 Y. And our first point will be 0, 7. Next point will be 0, 10. Next point would be 2, 8. And the last point would be 5, 2. As I say, you can get these intersections pretty easily just by setting one of these lines equal to the other line. Okay, so let's go and plug this in. So we're going to have 2100 here, and then 3000 here. Okay, so now 2 times 500 is 1000. 8 times 300 is 2400. So that's going to be 3400. And then this one, 5 times 500 is going to be 2500. 2 times 300 is 600. So it's 3100. So this is our keeper right here, 2,8. So the farmer's going to plant 2 acres of wheat, 8 acres of rye, and the profit from that is going to be $3,400. That's the most that the farmer can make given the constraints of his farm and his budget. Okay, so hopefully that wasn't too much too fast, but I'm trying to keep you out of the weeds here, so that you can see the big picture and also look at a graph that's fairly easy to read versus my scribble here. Okay, so hopefully this was helpful to you, and I'll see you again next time. Bye-bye.